My name is Chian Lim, and today I'm going to talk about the fourth experiment of Physics 20-12, which covers circuits. For the introduction, the purpose of this experiment was to adopt principle of energy conservation and current conservation, specifically using the node rule and loop rule to first predict the behavior of circuits, secondly, measure actual values of current and potential difference, thirdly, examining behavior of ohmic resistors and capacitors. The result will be explained throughout the slides by comparing assumptions with the results or the observations. And for this experiment, the assumptions and initial conditions would be that there have been negligible resistance on emitter and wire since it's tunnel line. The system and surroundings are defined below, and the initial condition and the equation that was used are also given. There are basically three most important concepts and equations that were used throughout this experiment. First is about the energy conservation, second is current conservation, and third is the Ohm's law that was used for calculations. This is what the first model looked like, and this is the second model that was used in the experiment. After the simulation via HTML page, it turned out that the expectations were exactly the same as the results, and also in a condition that one emitter is replaced by 1 voltmeter, the result turned out to be 3 volts for voltage and 0.00 ampere for the current. These are the models that was used to figure out the values, and the results also shown in the slides. Also, regarding the potential for the round trip, which should be 0 volt according to the loop rule, the overall voltage turned out to be 0 when the calculation was done, and the current still being 0.02 ampere. No change in ammeter reading due to high resistance and voltmeter contributed to this result, and this indicates that there aren't any current flowing, plus the same current remaining in the circuit. These are the results that was shown after when the ammeter was put in parallel positions. The reasonings and the results are also given below with the calculations. This graph drawn shows the tendency of how voltage changed throughout the circuit. Experiment 2, which used a different model, the result turned out to be that regardless of the connection of the battery, the brightness of the bulb decreases from the most brightest state and fades out, and like the same also applies to current, which decreases from its maximal value. The time for the discharging took 10.3 seconds for 10 ohm and 20.5 seconds for 20 ohm. But this result there might be errors and discrepancies on the results. Given these conditions, the experimental value for the slope and the value for RC was expected to be 6 seconds, and this matched with the expected value, which is resistance times the capacitor. Also turned out to be 6 seconds. And discrepancies for the model, most of the error was caused while in the process of time measurement, and there it should be noted that there weren't that many samples for the graph. The answers for the what if and why question would be that for the first one, due to resistance and ammeter decrease in current to be observed, and for the second one, due to resistance in wire, it'll take some time for the battery to be charged in real life. Thank you for watching the video.